Hello, how you doing? And welcome back to Wi-Fi Sheep right here on YouTube with me, Tom, and part 2 of our Seed Studio Wio Terminal review video. If you're not up to speed, do go and check out part 1. It should be on the screen right now. But basically, just to recap, I was contacted by Seed Studio. Now, they are a huge name in IoT electronics, in hobby and education sector, so you may well have heard of them. I certainly had. And they contacted me and said they'd like me to review a product for them. Normally, I'm kind of dubious to these things and I say, no thank you, because it probably wouldn't interest me and it's unlikely to interest you. However, what they offered me was the Wio Terminal, and I actually have mine here we go. And this thing is effectively a super powerful Arduino unit. It can run self-contained or it can run as an Arduino. It can also interface with Raspberry Pi. It's almost a kind of ultimate universal machine if such a thing existed. Now, I thought this sounds a little bit too good to be true, but in part 1 we did an unboxing, we got the thing powered up, it was super easy, it was super effective, and the thing was actually built really well. Now, for many of you that are still not convinced about this, welcome to part 2. Today we're going to look at actually how to get the Wio Terminal to do something useful for us. And first of all, we'll start with how to reprogram it, to make it do something that you need to do. The amazing thing about the Wio Terminal is that it has an online resource it can hook into called Codecraft, which is an online website and a building block type system similar to that of MIT's Scratch. It means you can actually build custom bespoke software for the device without actually needing to know or type a single line of code. Let me show you. So first of all, we need to head over to IDE.tinkergen.com and it brings up this fantastic site from Codecraft. This allows you to actually program hardware within browser, and you can see a number of boards it supports, including boards you've probably heard of and know of already, such as Arduino and BBC Micro Bit. What we're interested in for today, of course, is Wio Terminal, which is here. So we just click and it opens a brand new session. Codecraft Terminal works very similar to Scratch. So I can now code something for my device without actually needing to write or know a single line of code. Before we do that, however, we do need to actually plug our device in. So I've got here my Wio Terminal and the supplied USB-A to USB-C cable. And we're going to plug this. I'm using a Mac here, but you can use whatever computer system you've got as long as you're running a modern online web browser. So Windows, Linux, and any variation of the Mac should be fine. So we're going to plug that in. And we do need to power up. To power up, we just push down, let go, and it goes into the powered up state. Okay, so for the Mac, you do need a piece of software called Codecraft Assistant, which you can download from the device module here. And that does need to be running as a standalone application, which I do have it here on the Mac running. So if we now go connect, and it'll pick up the port we want under USB modem on the Mac. This will be a little bit different depending on which system you're using. I say connect, and we've now actually connected successfully to our terminal device. Okay, so what can we do? Well, we could build a very simple program. So we click on System, and just like Scratch, we click and drag. So we've got a setup and a loop. So we could say on setup, set background color. And we could pick a background color we want, any color we want really. So let's say we want green. Let's have a look under, we've got operators. We can set variables, we've got control. So we've got delay. So if we set up a loop, we could delay, and that's milliseconds. So let's say I want 2000, which should be 2-second delay. And I could set my background color again. I can duplicate this piece just by right clicking and duplicate. So we'll go red, then this, let's say green. So we'll select what green we want, which is that's what green, and we'll do an RGB. So we'll say blue. Okay, so it sets up. It sets the background color to yellow. Then it pauses. Then it sets it to red. We'll set to green and set to blue, pausing 2 seconds each time. So if we want to try out this code, now we've connected our terminal, we can click to upload. This is where you want to upload, and of course we want to connect via our serial port, which is the USB link. So here the terminal's now switched off, as it's now receiving new source code. There we go, yellow, red, green, and blue. And it will just keep running in a loop. You can see here it says it's been successfully uploaded. You'll also notice on the Mac, when you upload, it kicks out what it describes as the Arduino drive. So you will get an error message because Macs don't like things being ejected. But don't worry about that. It's fine in this case. And there we are. So that is a brutally simple program. And we've actually got to the terminal to do something. And that was what? 2 seconds. I haven't written a line of code at all. What is really nice is if we actually want to see what this would look like in the Arduino C code environment, there's a tab up here and we can click. And we click from sort of object grabbing mode into terminal text or code mode. And there we go. There is the actual code, which is a variation of the C language, to make this system work. So it includes the library, a .htft library. It sets it up, and then it opens up our loop. And you can see in the loop here that we're delaying and we're setting up fill screen variants. And there is the colors we selected in their hexadecimal formats. What is very useful about this is we could copy this code. It is straight C. We could copy, and if I wanted to, I could open up an Arduino IDE space, and I can just delete the default code, and I can paste in, there we are, the code that we've just taken straight from the Codecraft online terminal, and that is actually valid code that we could upload. Of course, to use the Arduino IDE, we do need to add some external drivers. To do that, it's very simple. We go to our preferences, and there's a link down here for additional boards. Now I've already got the .json file pre-installed. I also have a board or .json for an additional board. So you may have nothing in this box, or you may have several things, but you just have to add the additional line. So here it is. This is the line that you can get from the Seed Studio support pages or the wiki. The links to all that are in the description to the video. So you do that, and we say OK. Then we'd head to Tools and Manage Libraries, and we'd do a search for Wio Terminal, and you'd see it would come up as the drivers. As I said already, I've already got the Wio Terminal hardware drivers installed, but you would search for Wio Terminal and it would come under SAMD boards, and that would install an entire library pack. I've got the separate library packs already pre-installed here, and you just click and you click to install the drivers like so. This now means that we can actually use the Arduino IDE to upload to our Wio Terminal. All we have to make sure we do is select Tools, make sure our board is selected under Seed. So here we have the Seed SAMD library, and we just have to make sure we got the correct product, which is Wio Terminal selected. And I believe that's all we have to do actually. Port, we do need to make sure on the correct port, which you see down here at the bottom. So that's fine. And we should now be able to actually upload this code. Now remember, this code has come straight out of the Codecraft online tools. I've just copy and pasted it into a new sketch here in Arduino IDE. Let's click upload to now compile. And there we go, it's been successful, and the device lights back up, and now it's running the same piece of code again, but we've uploaded it straight in C from the Arduino IDE without using the online web tools at all. So you can see how easy and how flexible Wio Terminal is to program. Okay, so that's pretty amazing straight off the bat. But what if we actually now want to use it for a project? Well, one of the projects which we've been running here on Wi-Fi Sheep is our very own TinyBASIC computers, which are custom 8-bit real programmable computers. Now, I wanted to know is, could I use the Wio Terminal as an actual video terminal and interface it with my bespoke hardware, as well as write a custom terminal kernel? Sounds all a bit complicated? Well, it actually wasn't. Let me show you. Here on the screen, going back to our Codecraft online website, I have here a very simple terminal which will do the trick set up. So we can see that we start by setting up a baud rate, which is 9600 BPS, which is what TinyBASIC Computer runs at. We can set the screen the correct way around. We're going to set a background color, a text color, a size, and then we're going to print TinyBASIC Computers, Wio Terminal. And then in the loop, we're going to open to ask, is the serial terminal available? And if so, to print whatever the serial terminal is outputting onto the screen and then enter a new line. So that should work really well. Let's just make sure we can connect. So make sure that Codecraft Assistant is up and running. And let's just make sure we can connect again. Excellent. And let's try uploading this piece of code. You can see TinyBASIC Wio Terminal has now shown up, be it in very, very small letters, but it's there. So this, in theory, should work. And if I click Roger, again, the Mac will complain about the device being injected. Don't worry about that. So I should be able to click on serial monitor. So I type hello. You can see that hello has appeared here on the screen. So we know this as a terminal is now working, but there is a problem which, doing the prep for this, I discovered, which the built-in serial tools here in the Codecraft environment, if I go serial port, you can open the serial port, select a baud rating, which is what we've done here, but it only opens a serial port for USB. Now with serial, there's three types of serial. There's USB, there's UART, and there's I2C. The one we want to use, and the one that TinyBASIC Computers uses, is UART. And that's not possible to set, as far as I'm aware, from this environment. So we go to the code, and here is the code, and you can see serial.begin is the line, but serial.begin on its own defaults to USB, which means that this wouldn't actually work if we wired it straight into our TinyBASIC computer. It's not possible to change these. So you cannot read. We're in a cannot edit. We're in a read-only mode, which is unfortunate. So, as before, we'll copy this code out and we'll shoot over to Arduino IDE and we'll paste this in so we can make some changes and we'll upload it from there. So, welcome to a new shiny Arduino IDE space. We'll just copy. Well, we'll select, delete what's in there, and paste in from the Codecraft site what we need. So really, to make this work, all we need to do is assign the correct serial, which I believe, if I remember, is, I think it's serial 1. So if we say serial 1, and then down here it's serial 1.available, that should set it up as UART by default. So making sure our system is set up as it was previous, we need to make sure that we have selected ourselves on the correct COM port, which we have. We can upload this source code. So that's going to compile using the libraries that we pre-installed from Seed Studio. So with the upload successful, we can see the Wio terminal here is running with our custom TinyBASIC terminal code. It's still being powered via USB-C at the moment from the MacBook. For the next part, now we've successfully uploaded, we need to disconnect. That, of course, will pull the power straight off. It's important to remember with the Wio terminal that the stock unit, which this is, does not have its own battery power. You can buy add-on battery packs for the unit from Seed Studio, but this one doesn't have one and we'll need to power it externally. So to do that and to connect this up, I'm going to use the breakout pins I've got here on my TinyBASIC PCB. Now these are this array here. This, bearing in mind, is a custom unit that I've designed myself. So it's not a stock unit in that sense. So I have these pins here, and we have TX for the UART serial, and we also have 5 volts and ground. On the back of the Wio terminal is a series of pins. These are compatible with the GPIO pins of a Raspberry Pi, but they are flipped around, obviously being a female connector, not a male pins. If you're unsure about the pins, the manual, which comes with the unit here, which is superb, actually has the breakout diagrams, and we can actually see the orientation and the pins in question, so we can simply line it up like so. So in order to make this work, I need 3 GPIO jumpers, male one end, female the other. So the black and the white will be our voltage. Now this is important to get this the correct way around. So what we're going to do is we're going to jump 5 volts off our PCB to power our terminal. So white will be 5 volts, and I'll plug that into the 5 volt line there. Here we have black will be ground, and I can go next to it on a ground line. And blue will be our single UART serial. So this will transmit data from TX, which is the transmission line here. So there's TX. And this will transmit the data to our serial terminal. So now we need to wire up the other side. And again, we can use our pin diagram here. Let's just bring that in camera. There we go, so you can see. So, and we have to, I must stress, you need to get this the correct way around. So we'll go 5 volts in there, ground, and then it has labelled here as TX and RX, and we want to go into the RX line. So it's TX is transmit, RX is receive, and that will go in there like that. And we'll now power via USB and a 5 volt iPhone or iPad charger. So let's apply some power. So the TinyBASIC board's come up and the terminal's loaded, and you can actually see already that it has worked successfully because it's loaded in the TinyBASIC kernel as we see on the project. So I've just plugged a keyboard in, so we can now test some input. So let's just ask it for memory, which we type MEM. There it is. And that'll read back what is on the screen. The font is absolutely tiny, but it's there and it works. So this would now work as a terminal. And if we actually reset by pulling the power switch down on the side, just pull it back up again, that resets. And I should now be able to just type 10 print hello. And list. There we go. It's not perfect because it is returning characters and putting it on a new line when just because I'm typing slow, but it is working. So that's fantastic. So that was really, really simple to do. You saw how simple and quick it was to build a terminal. Now, this terminal needs a lot of work, but it does show how versatile and useful the Wio terminal can be for an existing electronics project. So there we go, the pretty amazing Wio terminal from Seed Studio. It really is one of those incredible devices. I've even taken this along to a recent Raspberry Pi Jam event, not because I was paid to, but just because I wanted to show other people there this device and say, have you seen this? It's incredible. I've also just recently, at time of recording in this video, which is late October, I've just checked to see if there's still stock, and there is stock, priced at $36 US. This would make the perfect Christmas present. If you've got someone in the family, or maybe yourself, that is a tech enthusiast or just starting out in Arduino or Raspberry Pi, this really is the perfect present, and it's such a good value as well. It's amazing. Do go and check out on the website. The links to all this are in the description to this video. I'll end by just saying a huge personal thank you to Seed Studio for sending me such an awesome product. I cannot recommend the Wio terminal enough. If you're brand new here to the channel, then thank you for your company. please do remember to like and subscribe, and I will see you real soon. Until next time, keep safe and bye for now.